So welcome guys, welcome to my YouTube channel. This is Arijit, your host. So today we'll be solving a optimization problem, and the optimization problem is that we'll be dealing with is a production planning problem. Production planning problem basically means what will be the products of a plant so that profit is maximum. So our objective will be to maximize the profit, right? So to maximize the profit, what are the products and what are the quantity of the products that needs to be generated, which will satisfy our constraint also. So our constraint for a plant, there are various types of constraint. To name a few, budget. So budget is a constraint basically. You cannot go beyond the budget. To if you go beyond the budget, the problem will be infeasible. Similarly, there are constraints from raw materials. You cannot you have a limitation of your raw material, right? Similarly, there are constraint of production limits. So if you are producing any product, you cannot produce that product. You have a minimum quantity that needs to be produced, right? So you cannot generate something which is lesser than the lower limit. Always have a lower limit, you have a higher limit. Suppose you are operating a motor, so it will give you some energy, right? It will give you some energy. So you cannot suppose for example, you are running a thermal power plant. So if you run a generator, it will give you some minimum amount of energy. You cannot demand just give me 1 watt, right? So this is the thing, these are the constraint which needs to be satisfied, and we have to solve our problem. Now this optimization problem can be solved by various ways, right? There are multiple techniques to solve the optimization problem. To classify this techniques, there are classical techniques, which are classical techniques are basically mathematical techniques, and there is one another technique which is the meta-heuristic techniques, right? So if you observe any optimization problem, it has a classification, right? So optimization problem can be a linear problem, can be a non-linear problem, can be a mixed integer type, can be a MINLP. So there are various classification. So in case of classical optimization technique, each type of optimization problem will have some algorithms to solve. That is, in case of mathematical optimization technique, there are some algorithms which are only suited for linear type problems. In case of mathematical type, there are some optimization techniques which are only suited for non-linear types problem, right? But what happens is that most of the time this optimization problem comes from a industry in a black box. That is, the industry people do not want you to give do not want to give you the mathematical model. So you do not have any idea about what is the nature of the problem, whether it's a linear type, whether it's a non-linear type, whether it's an integer type. So most of the time people get stuck on what type of algorithms to use, right? So that's why we will be using a different class of optimization technique, which is a meta-heuristic technique, right? So meta-heuristic techniques are basically optimization techniques which are inspired from nature, right? You can say nature inspired optimization techniques, okay? Or heuristic type techniques. So in this type basically they uses the algorithm uses it basically are inspired from nature, right? So for example, PSO, take example PSO, which is basically inspired from a swarm of insects or birds, right? Flock of birds, swarm of birds, right? So particle swarm optimization is basically the name of that PSO. And another is TLBO, which is basically inspired from classroom environment. Thirdly, to name a few, will be differential evaluation. Then there is genetic algorithm. So the benefit of using these meta-heuristic technique is that it it treats any optimization problem as a black box problem. So it doesn't matter whether a problem is non-linear, linear. It will these optimization metaheuristic technique will treat the optimization problem similarly, right? So another benefit of using metaheuristic technique is that it's a multiple point based search technique, right? So what happens is that in case of nonlinear problems, there are multiple optima points. So there are various local optima points, and there is one global optima which we don't know, right? So where it lies. So the in case of classical techniques, most of the time what happens is that these optimization problem get these techniques get stuck in local optima, right? But the benefit of using metaheuristic technique is that as it's a multiple point based search technique, it there are very less chance for the algorithm to stop at a local optima. And uh, though in the literature it is said that it will not guarantee you the optima point, but still it will guarantee you, almost guarantee you that it has been seen that it almost reaches the global optima, right? And that is the fun work of, right?